again to my channel. So today we are going to learn about our next topic, which is model regression modeling. Let's start. Sorry, it's logistic regression modeling. I'm sorry. Let's start. Logistic regression modeling. It's a key tool for binary classification, logistic regression. It is a statistical method designed for binary classification tasks where the target variable has two possible outcomes, such as 0 or 1, yes or no, or true or false. It predicts the probability that an observation belongs to a specific class using logistic function, which transforms outputs into variables between 0 and 1. Model explanation. So this model, it computes a linear combination of input features such as of beta and x1 and x2 and x values. The value of set is then passed to the sigmoid function to calculate the probability that target variable belongs to class 1. And here is the formula. So if by is equal to 1, it exceeds a threshold commonly 0.5, then the observation is classified as class 1, and otherwise it is classified as class 0. So the key assumptions are if linearity in log odds. So the relationship between independent variables and log odds of an dependent variable is linear. No multicollinearity. Independence of observation. The data should not have an autocorrelation or dependencies among observation. Now evaluation metrics. So to assess the model's performance, several metrics are commonly used, which is accuracy, the proportion of correctly classified observation, precision, the proportion of true positive predictions out of all positive predictions, recall or sensitivity, the proportion of true positives detected out of all actual positives, F1 score, the harmonic mean of precision recall, ROC AUC score, it is a measure of model's ability to distinguish between classes. Then applications. So logistic regression is widely used due to its simplicity, interpretability, and robustness. Robustness. So common applications are spam email detection, which is classifying emails as spam or not spam. Then disease diagnosis, which is predicting presence of a disease based on medical results. Credit risk analysis, which is assessing the likelihood of loan default. For multi-class problems, logistic regression can be extended using models such as one versus rest, which is OVR, separate binary classifiers for each class, or multi-novel logistic regression, which is directly models for multiple classes. Then why use logistic regression? So logistic regression remains a preferred choice for binary classification tasks because of its simplicity, efficiency, and effectiveness. Now it strikes a balance between simplicity and performance, making it foundational tool in machine learning and statistics. Now how to perform logistic regression using Python. So it is a widely used algorithm for binary classification tasks and it is a step-by-step guide you can see here. First we will import all the libraries, pandas, and then the train test, logistic regression, metrics import. Then we will prepare the sample data set. Then we will train that logistic regression model, the set into logistic regression model. Then we will make prediction out of that model. Then we will evaluate that model. Then we will visualize the ROC curve and then display it. So data preparation, the dataset is split into features X and target variable Y. That is further divided into training and testing sets using test spread. Then model fitting the logistic regression model is trained on the training data using the fit model. Then we will make predictions that predict is used to generate classic labels for generate test and predict underscore provides computed probability estimate for each class. Then model evaluation, that is accuracy, will measure the correctness. Confusion matrix, false positive and false negatives, true positives and true negatives. Classification reports, it provides precision, recall, F1 score, support. And then it is ROCA uses which will assess the model's performance overall classification thresholds. Then is visualization. ROCA when you use will do that. Then we have how to perform Poisson regression using Python. So it is a statistical technique used to model data count where the dependent variable represents number of events occurring within a fixed interval of time or space. This method assumes a report variable vectors on response, the variable through Poisson distribution, which its mean expresses function of independent variables. So firstly, we will import all the necessary libraries required. Then we will define the Poisson regression model. Then we will fit that model using stats model, then to the model summary, then to the predictions, then evaluate goodness of it. So firstly, we'll define that data, prepare the dataset where dependent variable is a count. Then I will specify the model using the API from stats model to find Poisson regression model. Then I will fit that model using the maximum likelihood estimation provided by Poisson function stats model. Then we will use the model summary to obtain detailed model information including coefficients and standard errors and p-values. Then we will apply the fitted model to predict expected counts for dependent variable. Then we will apply goodness of it, which is deviance, which will measure how well the model fits in data, and under what deviance indicates a better fit, and null deviance, which is compared the current model to null model. So this approach is ideal for modeling count data and assessing relationship between variables in scenarios where even counts are of interest. So this was all for today, and thank you so much for watching. Thank you.